when you take into account the different kinds of ways you can transform a function, it makes sense to establish some sort of order to that. So here's the order I like to use. And we would start, as far as describing or implementing ways of transforming a function, I would think about, is this being reflected across the x-axis first? After that, then think about, has it been stretched vertically? And then a horizontal shift, and then vertical shift. And the reason that we need some sort of order to agree upon is because, for example, suppose I took that absolute value function and I said, well, first let's reflect it across the x-axis and then do a vertical shift by down 2 units. All right, so here we go. And I'll just make this kind of small and sketch it. But if I were to take the absolute value function and reflect it and then shift it down, it would look like this. So that was reflection and then vertical shift. Now what if I reverse the order on that? If I were to do a vertical shift of down 2 and then reflect it around the x-axis, if I did that reflection, then you would end up with this, the red one. So here we have reflection first, then shift down. Here we have shift down first, which is the blue, and then reflection around the x-axis. And they're different graphs, okay? So the red one is comes above the axis, and the blue one doesn't. So the order of these transformations is not reversible always, and you might say it's almost actually non-commutative. All right, so we had to worry about that aspect of this. So when I describe things, then I'm going to adopt this order and doing them. And I think that's more my worry than yours, as it turns out, because I'm the one who frames these questions. But anyway, you'll see that. Now, we're going to get into combinations of transformations. And let me just do a quick one using our absolute value. And then we'll get away from the absolute value function and pick on some other function, just sort of for variety's sake. All right, so I'm going to erase the board and make up a function here. Here's my function. Graph y equals to negative 1/3 times absolute value x minus 1 and then plus 4. All right, so what I'm going to show you now are 3 types of problems I want you to be able to handle if you're my student. All right. The first one is I will give you a graph of a basic function, and then I'll ask you to graph a transformation of that function. Now we've already have worked with this absolute value graph, so I'm not writing that up here because you have this already. But say on a test, I would draw a graph on the test and tell you what that function is, and then the first type of question is, here's a new function, graph it. For that, we need to know the transformations, of course. And what are the transformations? Well, it has been reflected across the x-axis. And how do you know that? It's because of the negative up here. So the negative of the absolute value. We have the negative means the reflection across the x-axis. All right, what about the vertical stretch? All right, so what multiplies the absolute value, which was our original function? It's 1/3, so we have a vertical stretch by a factor of 1/3. What about the horizontal shift or translation? Well, x was replaced with x minus 1, so when we replace x with x minus 1, that means it goes to the left or to the right? It goes to the right. Remember, because the horizontal shifts run opposite here, in a sense. So this was shifted right by +1. And that's how I notate it with a shorthand notation. Now, this notation is for working convenience. It's not for communication to someone else, except for me communicating with you. But I'm just taking notes here on what's happened to this function. Reflect across x-axis, vertical stretch by a factor 1/3, shift to the right by 1 unit. And what was the vertical shift? Well, the absolute value function was transformed in 3 ways, and then here's the 4th way. 4 is added to the whole thing. So that was a vertical shift of +4. So it went right 1, up 4. Okay. Now then, let's go ahead and try to graph that. And oh, let's see. It was reflected too, wasn't it? Well, I think we're okay. Alright, well, I'll start with that. Hopefully it will fit nicely on here. Well, I regret not having the original absolute value function up here. My board's a little cramped, but I'll just sketch it real fast. Here was the original y equals absolute value of x, just for reference point purposes. And now, as far as graphing, although I had the transformations described in that order, as far as graphing, you might look at the horizontal and vertical stretches first. Now, here's kind of a secret to this. If your graph goes to the origin, you've got a real advantage, because the origin is unaffected by reflection. It's also unaffected by stretching. So the only thing that affects the origin are the horizontal and vertical shifts. And so that means this point, which happens to be a really critical point in this graph, right? It's the one place that's really unique in the absolute value function is this vertex down here. So it went right 1 and up 4. So it's up here. All right. Right 1, up 4. I'll put scale numbers in at the end, but I'm using singles for scale numbers here. Well, that took care of those two. Now it's going to be reflected, so that means it runs upside down because of the reflection. And then it was stretched by 1/3. So now here, when you go right 1 unit, you go up 1 unit. There's a 1-to-1 ratio, or right 2 up 2 units for the absolute value function. When you stretch by a factor 1/3, that means that when I go right 1 unit, I'm going to change vertically by 1/3. And in fact, you would have to go right 3 units in order to get a vertical change of down 1. So it would be over here, wouldn't it? So this one is rather shallow, like that. There we go. And again, stretched by a factor of 1/3 means that these comparative changes are all compressed or divided by 3. So for example, on the absolute value function graph, if I go right 3 units, I go up 3 units. Here, if I go right 3 units, my change is 1 unit in the opposite direction. In the opposite direction because of the reflection. Got all that? All right, so put a couple scale numbers here. And there's the graph of this function. All right. Now, if I had graph paper, it would look a little neater, wouldn't it, with a straight edge? That'd be great. So, all right, so that's the first type of problem I want you to be able to handle in this section. If I give you a graph and a function, and then I give you a new graph, new function rather, can you use the transformations to graph it? All right, that's task number 1.